I've been asked to go through an example of the denotational semantics. Somebody was having some trouble on the homework. Note that I've posted all the notes that I had. So if you have that, you may have the book also. I think there's one of the book chapters I found online on denotational semantics if you need some help. Okay, but I thought I would go through the mechanics of this. This is the book example, but I'm going to expand it as we go along. Okay. So let's say that we're going to create a mapping function for a statement of the form while some Boolean condition do some statement. Okay. So, and that's not any particular language. I mean, it may be some language, but we're not sure which one it is. Okay. So again, we're trying to get here to semantics, to the meaning of this, what's really happening. Okay. So again, the denotational semantics, kind of like the operational semantics, deals with state changes. Okay. And those state changes, instead of using a finite state machine like we would with operational, we're going to create this mapping function that, given a certain state and some condition, what state are you going to get back? Okay. So again, we're going to define state as a series of ordered pairs of all the current value of the variables. Okay. So whatever variables you have with their current value is the current state, which we're going to call S, small s, typically. Call it whatever you want. Okay. So I've got an example here. This is kind of C looking code, except we don't have the do in this format here. Okay. So we have an assignment statement. We're letting X equal 10. We're doing, and I'm not assuming any of, it's declared before that and all that stuff. So while the X value is greater than 0, we're going to do the following statement. X, we're going to reassign to 20. Okay. So that's where we're at here. Sorry, my pups are being rowdy. I had to pause the recording. Hopefully they'll calm down. Okay, so that's the idea there. Okay, so if you look at the state at the start, at the time that we hit the while statement, okay, at this point we have the S is equal to curly braces. The only variable that we have defined is X. Now, a real program probably has a lot more variables defined, but we're keeping it simple here. Okay, so the state here is X has a value of 10. Okay. When we're done with this loop, since we know the Boolean is true, we want X to be equal to 20. Okay, so I've got S here, but that's really going to be, let's say, in this sense, S1, S sub 1 or S1, whatever you want. Okay, so when we're trying to specify this while loop, we want to think about all the options that we have. Okay, and the first issue is going to be on this Boolean condition itself. Okay, we have to think about how we're going to specify what can happen with that. Okay, well, I guess before that, we kind of need to start what our problem is going to look like. Okay, oh, the other thing that we need, if you want to do all of this, the mapping functions for everything, it's going to take you the rest of your life. Okay, so we're going to make some assumptions here. The book does this as well, and you can do this in your homework problems. Make these kinds of assumptions if you need to. These are things that are not directly in this structure, but have to be there. They're supporting materials. Okay, so we're creating this M sub SL function. Okay, that is going to take a list of statements, okay, and a state, and convert that to a new state. Okay, so that's going to execute a statement basically, and it's going to take care of the semantics or the meaning of that statement. Okay, we're also going to have an M sub B mapping function, which will map Boolean expressions to Boolean values. Okay, again, the expressions are what we're actually going to, what we type in for them, a true or whatever. The values are the actual Boolean types, the zeros, the ones, whatever we want to call them there. Okay, so again, we're going to create this function ML to map our statement to a new state. Okay, so this is what we're going to start with. So we have the ML, M sub L, our while B do L. Okay, else as many things as we want, as many lines as we have, okay, and the current state. And then the delta equals is just what they use as their mapping function definition symbol to keep you from getting confused when there are equal signs other places, okay? So now that we've got our problem statement, the first issue is going to be B, okay? What can go wrong with B? Okay, we're going to deal with those things that have gone wrong, okay? So the first thing about B, it could be undefined. We could have a statement it's like about here, like X dot 5, which MB can't convert into a true or false because it's not, right? It's at least unless we've defined a dot, but let's say that we have not, okay? So we have to worry about that condition first. That would lead to an error state, okay? So now we've got, again, what we had before, but we have this if statement here. We're going to say if the mapping function for B, if we give it the B, which is what we're basing our while on, okay, and given the current state S, which is where we're currently at state S, okay, if that is undefined, then we have an error. Okay, that's all we have to say for that. Okay, that's one possibility. Okay, the next possibility is that B is false. B evaluates to the Boolean value false. Okay, in that case, the state shouldn't change. Okay, so to specify that, we're going to say else if, and this else is inside of the if. Okay, M sub B of B, a Boolean expression at the current state, is equal to false, then S. We're not changing. Nothing changes. Okay. So those are the two things that will delay us. So if we get to the next point, then we know things should be okay. Okay. We know we're able to execute L. Okay. But with L, we have to worry about what if L can't be executed. This is where the M sub SL comes in. For a given state and a given statement L, are we going to reach an error condition or not? Okay, so we're going to check that. Okay, we're going to use this MSL sub LS to take our statement or statements, it could be more than one, okay, and given the current state and see if there's an error. So we're going to say else if M sub SL of the statements we're doing, given the current state is equal to error, then we have an error. Okay, so we know that. So we have now two possibilities with an error. We have an error if the Boolean is undefined, or we have an error if the statement or statements L lead to an error condition. Okay. So finally, if we get through all of that, okay, we're down to the else where everything's okay, we can go ahead and execute to get the next statement. Okay. And we get the next statement by taking our statements L, which we now know are not going to produce an error. Okay. We've gotten here because we know that B is true. Okay. And given that L and the current state, this function, let me highlight that for some reason. There we go. This function is going to return S1 or the next state. Okay. And we're putting it this way so we just know what's happening. So to sum all that up, here's how we do that to kind of see the flow of things. Okay. So again, to read it again, we're saying that this mapping function for some statement L, okay, we're going to put it in a while B do L with the current state S. Okay. If the M sub B function for Booleans of B at current state S is undefined, there's an error. Else, if that same function, the Boolean function of B at S is false, then we stay at S, we stay at the current state. So the variables are all the same. Else, we're going to try to execute L at S using the M sub SL mapping. If that maps to an error state, okay, there's something wrong with the syntax of that language or that statement or statements, we get an error. Okay, so then we have our error. Else, we've made it there, life's good. We're going to apply the L statement or statements to our M sub SL mapping function, and that will return a new state. But we're giving it the current state. And I guess I can make that more clear that this in essence, this part is going to give us the next state. Okay, S. You could call it S sub, whatever you want to call it. So let's do a S sub 1, whatever you want to call it. Okay, that's the idea. Okay, so this is very similar to the homework that asks you to do a Java do while loop. Okay, the difference being in the do while loop, you're going to execute L first. Okay, then you do the test. Okay, and that's going to be very similar. Okay, the others should be about the same. Okay, so a couple of other just notes if you make it this far. I've added a problem set for the stuff we did yesterday for the lexical and syntactic or syntax analysis. I've also added a problem set that includes a couple programs for the binding name and scope, which we're doing tomorrow. Okay, So those are all out there. I don't know if we're going to make it all the way through the material tomorrow. It may take tomorrow and Monday, but we'll see where we're at. Okay. Anyway, all of that is due Wednesday. Okay, next Wednesday. So that gives us a little more time to work on things. We're coming up on when we need our first test. Hopefully, if we can get everything together by Wednesday, we can review on Wednesday. I'll make sure you have the answers to all the homework problems on Wednesday, and then we can have the exam on Friday. Okay. So that's where we're at. If you have questions on any of that, make sure that you let me know.